So today I wanted to talk about, I just titled it Simple Validation Testing and Deployment for Python Web Apps. Little background. This talk kind of came out of some questions and conversations about, some curiosity about how people are deploying or testing their Python web apps. And like any prideful developer, I kind of had to, I half put my hat in the ring and said, like, I'm happy to share my experiences, but I'm not quite confident enough yet to say, like, I have the best practices or here's the superior approach. But I think when I there's enough interest, like, well, let's just have kind of a lot of conversation and talk about it. But what really developed was this idea of, again, not everybody's, the most sophisticated operation in the world. If you came here looking for like deployment by Instagram or something of that scale, again, that's not going to be here. Really the goal, and it's kind of something more in the space that I live every day, which is how do I do something either from, solo side projects, small teams, how do I get that initial capability in those categories, testing, validation, deployment and stuff, how do I add a little sophistication? And that's why I'm going to kind of show you some hopefully relatively simple things that you can be doing. I really like the idea that this is something you could just add over the weekend, right? None of these are, major investments. None of my teams have dedicated DevOps or sysadmin staff, and that's kind of why you pick up these skills. You tend to have to do them, on top of, all of the development you're already doing. So first of all, I kind of skipped over myself. My startup's called Sublime, 2 B's, S-U-B-B-L-I-M-E. And again, you're just going to see a lot of examples. None of this is, terribly specific in this presentation, but obviously I'll give you examples from what we're using. So it helps to know a little bit about our stack. Hopefully it's relatively familiar or comparable to some of the work you guys each are doing. But we're Python, we're Django based. We need databases on our systems, MySQL and Redis. We got some front end stuff that will probably be the last time I mention. We use Nginx, which is pretty popular, and then we're EC2 AWS hosted. Again, obviously popular, but you'll see that in a lot of the examples. I'm just going to take all of this for granted, and obviously the exercise will be the reader to adapt these things to their individual environment. Same thing on the services. We host our code on GitHub. I'll talk through using Jenkins as a continuous integration. Same thing with Sentry to do kind of error reporting, SendGrid. Some of these other things, again, won't come up again, but just give you an idea of what's out there. All right, so let's talk, and I think the key to this conversation about validation, testing, deployment, it all ultimately goes under this pillar of software quality assurance. And the way I'm going to talk through it is I think there is this staged approach. And just to kind of take an aside on that story, on my own personal background, I spent actually much of my career in the aerospace industry, and it's an industry that takes quality assurance, to the extreme. And again, and it's really down to the cost of quality, right? Everything comes with a cost, and obviously, if you're building airplanes, there's a high penalty to defects and failure. And so so I want to kind of frame this entire presentation and conversation around the idea of what, in aerospace specifically, they focus on the idea of identifying and resolving defects as early as possible in the delivery of the product. So if you think of, like, say, manufacturing cars, when they're at the drafting table and they're designing the schematics for a car, if they identify, a defect in their design, it's very simple. It's pencil, paper, so forth. They can just correct the design. If that defect escapes that stage, it's later, they're in manufacturing, they're building the car, they're assembling the car, they identify the defect. Now the cost is a little bit greater because they got to go back, rework the product, and perform all the repairs on all the vehicles they've already manufactured. You go one stage later, if they've delivered those cars to customers, now you've got to recall. You've got to go to the customer's place and perform the repairs. The costs just become incrementally higher. So the approach with quality assurance in that general context is to try to incorporate processes in your development pipeline so you identify and resolve those defects at that earliest possible stage. And with that, I think I kind of consider these stages in the software context. And so and again, I just picked these names. There's a validation stage, which is practices you can implement. When you're writing code, when you're developing, you can identify possible bugs you've created or issues or challenges there. I have what I'll call a testing stage, which is really kind of that checklist of things you do before you're ready to deploy. Right? We all do them manually anyways. You click on a couple buttons, you run your code, make sure nothing crashes out. Obviously, again, it's trying to incorporate all of that functionality in a more, and again, think of it in a process-oriented way, so it's repeatable. And obviously, again, this is where a lot of the automated tests come in. I break testing down into 3 different categories. I have the unit testing, which I consider in an isolated component context. The goal is to validate that each little cog in your architecture and design operates based on the expectations. I have what I call functional testing, which is when any of your components need access to an external API, external systems. You've got a caching layer, you've got an email delivery system, whatever it is, something that kind of relies on network connectivity or an external system. And then the final category is this acceptance testing, which is usually the user-centric model, which is you focus on how the users interface with your systems. This tends to be like Selenium, where you kind of poke and prod your system with a browser. And obviously, a portion of this conversation or of this presentation is leveraging continuous integration, again, to really automate that process, to really incorporate it into your development cycle. And then I think it's the last stage, which is that after you deliver to the customer, is having monitoring in place. And I think there's 2 categories there. It's using exception tracking. So when something does go wrong, you can do a post-mortem and figure out what the root cause is and collect the data. And then just more of a general health check. You want to have measured performance, response times, uptime, that kind of stuff, right? And then just to kind of talk about, again, back onto my specific project, this is what, I did a quick run through of our code base, just to give you an idea of the scale here. So I calculate 153 source lines, 4,600 lines of code. Our code coverage, our testing suite tells us the code coverage, just for kind of a frame of reference. And then the tests we run. So we have a fair amount of unit tests, almost 300 now. We have 15 functional tests that, again, tend to hit an API endpoint or something, so they actually run fairly slow. And the last one, which we use Lettuce for our kind of end-to-end testing, we have 8 features that run 30 different scenarios through our code path. All right, so that first category is code validation. And again, the focus at this stage is really just trying to help you, find tools and processes that can help you, catch those gotchas. And they tend to be at this stage, the really obvious ones when you look back, typos, mistakes, I called the wrong function signature and stuff. And the 2 that I really emphasize is, one thing that really helps, obviously, in any kind of team, especially in a team environment, is having a strong coding standard, a consistent way you define your code. So I always advise, if you're not doing today, kind of create a PEP8 type of coding standard. I'd say PEP8 derived, because I take PEP8, and I'll show you on the next slide. I come up with exceptions that go against my own preferences. But then have some way to validate that. And then again, it forces your code to be in a much more consistent structure, which again, A is obviously beneficial. The more consistent it is, the easier it is to spot issues and challenges. And then again, obviously in a team environment, having that consistency is really helpful. And the other thing that I'd recommend is add something like PyFlakes, and there's other static analysis like PyChecker. But incorporate that into your development flow. Get something that, again, it's a static analysis tool. They tend to find unused code, incorrect symbols, and those kind of errors that are a great way to kind of be that first level detection of possible defects.
Regarding that question, IDE editor plugins, do you have any plugin that can catch the mistakes as you go along?
Yeah.
Okay.
And that'll actually be the next slide.
Okay, thank you.
But so I'll pause on that for 1 sec. And then, yeah, obviously, not only do you want to have this running continuously while you edit, right, and have it is integrated into your actual authoring process, and if it's not in your editor itself, have some background process that can run or whatever, you can do. You also obviously want to make this part of that testing. Part of your continuous integration is to calculate, the compliance of these standards. The first thing, again, this is an example. This is my .pep8 file, which is where you configure. There's a programming or a module called pep8 that performs the validation. And again, it ultimately takes what was captured in the PEP8 standard. And then again, now it's starting to be very subjective. These are my preferences for how I like my Python code. And I can see Mark's our one other developer, and he has to suffer through my decisions since I made them ahead of him. But I mean, again, I'll skip through most of them. But again, line length. I'm not a sticker on having a 79 length. I actually use tabs instead of spaces. Some blank space stuff. But the nice thing is, again, you define them, which is if you look all the way over here, that ignore equals, it just captures what the agreed upon rule set is. So when this PEP8 checker runs, it will detect anything that's basically not excluded here. So it's really good to see, make sure the spacing's right, the line continuation, and so forth. Again, some specific things. So I exclude, we're a Python Django project, so I exclude migrations folders, which are auto-generated code by South, which does the database conversions, migrations. They're auto-generated. They're not compliant. I don't care. I'm not editing the code very often. So obviously, I don't want to have to fix them every time I generate them. And then I mentioned PyFlakes. There's actually a package that combines PEP8 and PyFlakes called Flake8, which basically comes as super extension. And I added one more exception there, which is, I guess, this F403, which is when you do a from module import star, which I tend to do when you need to kind of just move stuff between namespaces. Config files tend to have that stuff. So I ignored that error as well. And likewise, there's an exclude on migrations, and then there's the -steps file, which are how you define lettuce-based testing, which kind of break a lot of the ways you'd expect people to import, because they have their own way to resolve, to convert symbols.
This is fed into PyFlakes?
Yeah, so there's a combination of a rule set for like PEP8, which is the coding standard, and PyFlakes, which is a static tool. So, and again, this is in version control. I mean, that's what I mean. This becomes kind of, something that the team should all agree on and share. And again, ultimately will help you kind of maintain consistency in your code base, and also, like I said, through PyFlakes, detect auto errors. And then the complement to that is, again, have it, that's a static tool. It's a command line tool. I have to run it. The continuous integration server will run that after every test. I'll show you later. But obviously, I want this as I'm working. So I use Sublime Text. There's a product called Sublime Linter that incorporates these same tools. So likewise, again, it's a different format, so I had to, there's a little duplication there, but I just copied the same list of exceptions for PEP8 there into this is in my project config for, for Sublime Text there. One commentary, one nice thing is you can actually, I tend to actually be more strict in this than what I validate from continuous integration. So I might have some rules that, I might be more lenient when I'm looking for violations, then maybe I hold to myself. Especially if you're migrating less standard code and you're trying to make it more standard. Kind of like, so this tends to only operate on save. So I kind of have that rule where like all new files need to, be to a higher standard. So, and again, I'm half oblivious, but I know there's equivalent things for almost everything, like Vim, Emacs, just about all of the editors that have some plugin architecture are going to have some of this capability. So find the one that works for you. All right, so that's a kind of violation thing. Again, it's just trying to supplement your own natural ability to develop code, and again, develop fast, right? That's half the goal, is to not slow you down having to think about some of these things. I mean, rather than visually check your code, have some tool do it that can do it more efficiently. So I think the next component is really integrating a continuous integration workflow into your code base. I think I just kind of take this aside here to highlight, to me, the #1 value of continuous integration is to be, I always call it like a tripwire. Like what it does by running all the tests and running all the checks, is it has something, I feel like I always treat it like a third member of the team or something. Like, again, it's someone else. There could have been a human on the other side of this interface, running the same list of, checklist and tools. And so, and then I highlight kind of the 3 issues, the areas that I think it's really effective at. Regression testing is probably the #1, right? You tend to write the test to prove that, your code works in some capacity. So obviously later, if you deploy a build and it fails, it's a nice way to catch that, your latest code update, didn't account for some impact. Related, I call it smoke testing. In that, again, it works really well when you have, again, an example in our product is we use the YouTube GData API. And so I have they're the functional tests that make those API calls. And so if YouTube wakes up tomorrow and changes their API, I'm going to know about it pretty quickly. And hopefully, again, in that defect model, well before my code gets all the way to production. And then the final one that works really well is if you have any customization in your dev environment. People tend to hard code paths and rely on specific configuration. And because if you do it right, your CI environment should match your production, which should be relatively clean. It tends to catch those gotchas where it ran on my machine type of issues. So then there's some other things, and the reason they're on this slide for me is because it's just something that I'm not using directly on my projects. But there are policies you can implement if you want to reinforce. One of them I just highlighted, mandatory code coverage and different things. People tend to have rules like, minimum commit message size and stuff like that to kind of reinforce, best practices. A CI server is a great opportunity to evaluate those kind of processes. Another common thing is people annotate the builds, right? You can annotate the quality of the build, pass, fail. You can auto tag, for release, different rule sets about how, each build that goes through. Because the key is the continuous integration server is going to test every build we deploy. So there's an opportunity then to have it, version, tag, whatever, your process is. And the final one, which is really kind of connected to that, is it's also an opportunity if you need to do any further packaging of your software, for deployment. If you want to build, OS packages like dev files or something like that, compile the code and push it to your PyPy mirror, whatever your workflow is. The CI server is a great opportunity to kind of also automate that process.
You have a minimum coverage, code coverage that you enforce in your company that you say, I'm not going to release until I hit a...
Well, so as I said, these are that's why I put them under optional or other. It's not something that I've institutionalized. Okay. Code coverage itself is a pretty, unhelpful concept. It doesn't tell you how well it tests it, it just tells you that one code path works. But it obviously is a relative indicator of the amount of tests and the amount of investment into testing. So I've definitely been on projects where people do want to, mandatory might be too strong a word, but it's obviously frowned upon or reinforced to have better or worse code coverage. And if you use Jenkins, they do nice little icons like storm clouds and suns and stuff like that to kind of reinforce that. And I think I might have a screenshot that shows you where you set those thresholds. All right, so this is the process, again, that I implement, and that's why I highlighted some of the features we have. But obviously, this is a pretty routine workflow. It's a pretty easy sequence. You push your code, again, GitHub in our case, wherever your code's hosted, it's pretty easy to add commit hooks to trigger this. But you push your code to GitHub. GitHub then uses a commit hook to trigger the continuous integration server to notify the server that there's a new build. The continuous integration server, it either runs it on its own instance, or in our case, it actually spawns a worker instance to perform the test. It'll check out that version of the code that was committed. It'll run your battery of tests, capture any results from that test, and ultimately there's rule sets for notifying. So again, combined, this is what it creates this really helpful what I call tripwire. So I can push my code. Obviously, you do the testing you want on your own environment to have confidence that you've coded it right, but I don't have to really stress about it. I can push it out. If I didn't get an email in 5 minutes, the code worked kind of thing, and it just gives you more assurance and confidence. And obviously, you get notified, in the alternate case, from these services. So specifically, the way I run Jenkins is I suggest we use EC2. And I think this is a pretty decent architecture where you can run Jenkins on, again, it's ultimately basically a web application as a master that's just both listening to service your users to browse the build results and so forth like that. And of course listens for that trigger from your code repository. So the nice thing is it can actually operate just fine on a very small instance, right? If you have different workers run your actual test. So I run on a T1 micro, costs very little a month to keep up. That's the only thing that has to run 24/7 so it can respond. And then what you do is you pair it in this instance. You create an AMI, which is an Amazon image that it can deploy on demand to run those tests. So what you do is you configure the AMI with all of the dependencies, with all of the libraries and support needed to run your tests. And of course, just clone it, create an AMI of that, and then destroy whatever original instance. And then when Jenkins is triggered, it'll spawn a new instance, on demand of that AMI to perform your test, complete the test, and then terminate it. So you don't have to have, more powerful systems running around the clock. Obviously, if you have enough code and you have enough tests that you run it around the clock, it will. But it gives you a fair amount of scalability, so you're not, having to pay for a huge footprint to have this capability. So I set up Jenkins calls them a job, which is these tasks that run your test. So I set up a different task or job for each of those categories of tests. It'll run the unit test, functional test, and lettuce test. And like I said, I'll talk through some of the implementations here, but then you also, obviously, you need to configure that job to be triggered based on this commit hook. Again, there's alternatives. A previous company we used, Shining Panda, which is kind of it's a hosted version of Jenkins. They manage all of the virtualization and instances like that. You just, you pay your whatever it is, 20, 30 bucks a month, and you get access to a Jenkins in the cloud kind of solution.
In your CI path, you go all the time from the beginning to the end. You generate all the reports, and then you give it to someone or the whole team? Or is this process 1, 2, 3 can stop at any point? So if you fail at code coverage or a PEP8 violation, are you going to stop the pipeline?
So the way I architect it is that I have these separate. You could run them in serially,
right?
But there's a couple reasons. One, these tests tend to have different dependencies and environments. So I like to separate it just on that. And then also, yeah, so if one test breaks, at least I know how the other tests perform. But so you tend to have, I keep them separate. But obviously, again, depending on your needs, you're welcome to run them. And I'll show you how to configure the test in the next slide. So you'll see how you can just basically, it's really a series of commands to perform the test. So you can obviously run them together or separately. So Jenkins kind of has a plugin architecture, which is where you get to kind of add on a lot of unique capability. This is kind of the list I use. I like GitHub OAuth. It's a nice way. It allows you to do access control. We have an easy kind of policy. If you have access to our code repo, you probably deserve access to our continuous integration server. So why create a whole separate set of accounts and access? So it's easier to just do log authentication through GitHub, minus the, once every other week when GitHub's down. So the next two plugins, again, help. So it's build timeout, which is, it's basically a watchdog. So if your build, you can say, I set it for something like an hour, which is totally unrealistic for the build to take. But you tend to find tests every now and again that just get stuck. It doesn't fail, it doesn't succeed. Maybe some API it needs to is unresponsive. Whatever it is, it's a nice way to just, again, prevent it from, like I said, keeping your worker alive, all month, just because, something got jammed. And it'll just kill it and restart it, which, again, usually unblocks whatever the challenge is. Kind of comparable, a complement, it's called Naginator. So it's a similar concept, but it's where the test finishes, but it fails. But the failure is somewhat temporal, right? And so think of external APIs, like a temporal 503 error or something like that. And what it'll do is it'll rerun the test a couple times before it bothers notifying you that the test fails. So I definitely recommend, again, we said I think it has one of those where the test has to fail 3 consecutive times to really believe that there's a problem with the test and not the environment or conditions. Cobertura is the code coverage package. It's the one that does the code coverage report. Obviously, if you're interested in that, you'll install that. It's Jenkins Violations is the one that handles all the PEP8 reports and the coding standard stuff. I already said EC2 obviously is what does all that worker management for you. And its throttle concurrent builds is a plugin. So by default, Jenkins will spawn as many workers as there are these jobs queued up. So I told you I already have 3 just for one project. So unless you throttle it, it'll try to spin up 3 instances. And again, I'm not in that much of a rush. They can just spin up 1 worker for the most part and run them serially. So why pay extra if you don't have the urgency? So I'll kind of go through the configuration. I didn't go through some of this administrative. I'm going to share these slides. I'll put them on the meetup. They're on the web already. I just have a local copy. So no one take notes or anything. But I'll just kind of go through some of the examples if you need some guidance on how to implement some of these configuration options. So one of the things is if you install that GitHub, the GitHub plugin, you want to configure the webhook. That's how you do the triggering for builds. There are alternative ways. There's a more generic, it's like a post. You can post to a URL endpoint to trigger the build. The nice thing about this is it like auto configures GitHub for you. The downside, of course, is you have to type in your GitHub user account, which is because GitHub doesn't provide API access or the other authentication means to configure their commit hook URLs. So, I mean, that definitely is up to you. But this is the easiest way to get that kind of integration up to speed. This is the EC2 area. So again, anything you can do with EC2, you should be familiar with these kind of credential stuff. Your key ID, your access key, obviously a region. So they do need an EC2, an SSH private key, because they're the ones that need to, Jenkins master has to connect to those newly spawned slaves. But you can easily create, a separate key just for that interaction. So it shouldn't be too compromising. And like I said, the other key is you specify, the AMI you generated for it to use those workers. The nice thing, again, instance type. So like in my case, I use a C1 medium. So I get a little bit extra horsepower, to make sure I can get through the test, as fast as possible. And it also, the nice thing is it matches our production environments. We use all C1 mediums for our app servers. So the previous one was the GitHub, the general GitHub, which does the commit hooks. So this is the GitHub OAuth. Similarly, again, so this is where this, again, the nice thing is I can make it so that anyone in our organization on GitHub, can be authorized to log into our Jenkins server. So again, similar list of things. You need the URL to GitHub in case you're privately hosted, and then client ID and client secret, which is pretty common if you ever use their OAuth for anything else. Then I think you also have to add the admin usernames. So that was like the general Jenkins configuration. This is now, I'll talk a little bit more about how to configure individual build tasks, right? The jobs. So like we said, there's definitely some options. If you didn't want to go through the commit hook route, you can have it pull your server, your version control. Obviously, again, that's not great for anyone's resources. That's why we do build when a change is pushed to GitHub. And that was that configuration we did last time. You're going to have to specify the URL to your project. Again, they support, it's not just Git, there's CVS, SVN, there's probably everything. I just haven't used anything else besides those. And you can also, I tend to configure a branch, so we use a Git flow model, so all our code's committed to a develop branch that's ultimately tested and then delivered to a master for deployment. So that'll be the common. Now I'll go to kind of the individual. So this is how you configure unit tests. I just kind of put the content here. You'll have to kind of see the screenshot on your own. But the key to all tests is you basically add an execute shell section, and that's obviously the commands it runs on on the worker thread, on the worker instance. And I think this is literally what we use for unit tests. Those variables are, I mean, you can just use those shell variables. They create like a workspace, which is where they check out the code. I create a virtual environment based on the name of the on the job. You know, install some, you know, pip install some requirements, and then I run. In this case, because we use Django nodes, I do .manage test. And the last step is I run that pep8 command, and I name the file pep8.report. Is what the output is, and you'll see in a later slide here how we validate against that. The other thing you have to do to set up your test is, so this is setup.cfg, but it's really just the flags that nose test needs. In my case, there's with doc test, so it'll run any doc test in your code. The key one is with X coverage, which is what does the coverage report. And then you need cover, well, cover erase, it just tells it to overwrite. Cover package is, you know, the packages you want it to root. So in this case, it'll be whatever your code's under. And then that with X unit, so it'll run it using that. It's some JUnit, XUnit, XML file that hopefully you'll never have to read. And then so what you do is you configure that execute. Shell is obviously the test that's run, and then you kind of configure a list of actions and reports to generate based on the result of the test. So one of them is called publish JUnit test result report. And so nose by default calls it nose test.xml. So you just put in that file name, and that's where you'll get an extra tab in your results, your build results, you know, that extrapolates all the code coverage and shows you that. Another one you would add is the report violations. And so that's where the pep8 comes from. And all you have to do down here is you put in that name pep8.report. Under, there's a pep8 section. Obviously, they have sections for all the different lint type of function programs available for the different languages. So that was unit test, functional test. Again, these are going to start being really similar. So again, very similar list of commands you run, or you know, at least we run to do functional tests. In this case, it's not using Django anymore. It does nose test, functional. I put everything in a functional directory. All that other stuff is going to be pretty much the same. So I just kind of wanted to highlight, I told you functional tests almost by definition, you know, because they rely on external systems, services, APIs, they're unreliable. So this is where I use that plugin. So you would add the option to retry build after failure. In this case, I set it to try again in 5 minutes. Right, so and then I think, yeah, number of successful fails. So it'll try, I think it's on the 3rd time of it failing consecutively in this configuration. It'll actually consider the build failed. Otherwise, so it's a nice way. It gets, if you don't have something like this, it can become very noisy. You know, when services go out, you hit rate limits, whatever the cause is that creates inconsistency between your runs. And then so the final one is lettuce. In our case, lettuce. So if you haven't used lettuce, I'm definitely glossing over the whole thing. But it's just a nice framework to run kind of Selenium tests. And then it's Cucumber for Python if you haven't used. And that might not help anybody with that parallel. But there's a whole structure to how you define tests. Just called the gherkin syntax, because everyone in Ruby loves every pun possible. But there's just a nice way to write stuff in English. You know, given this, then do that. But it's also a nice way for us to test these, like I said, it's the end-to-end testing, or I always like to call it acceptance testing, right? And so you write things like, given the user logs in with the right password, they should be shown their account page, you know, and it's going, and there's just a lot of components though. This isn't unit testing. I'm not testing that, you know, my views look good, my models operated correctly, my templates rendered, it's everything, right? Every component in the system needs to work in concert to deliver this capability. So it's a nice way to prove that all these components are working together. So, so again, but from the continuous integration, again, similar kind of thing. All I'm doing is I need to set up, you know, my environment, and then I just run these tests in this case. And the specifics of how you configure lettuce will have to be left for another time. But lettuce has a similar with XUnit flag. In their case, they generate a file called lettucetest.xml. So just like we did in the unit test case, you say, you know, I want the JUnit test result, and it runs lettuce test, and that's what it it captures in the test result report.
Is this the same test platform like Cucumber, but Cucumber uses Ruby, I assume,
Right.
correct?
So
And this uses Python?
yeah, Lettuce is kind of a re-implementation of Cucumber for Python.
Okay, is it from the same folks or a different?
I think it's just inspired by it. It's
Okay.
unrelated. Okay, so I think this is one of those, to me, it's always the real easy, low-hanging fruit is adding Sentry. I'll talk you through, again, it's obviously, all of this is high level, but it's relatively easy to spin up Sentry as an exception tracker, and this becomes really instrumental, right? This is how you answer, the phone call of like, I'm clicking on the button and nothing's happening. And I tend to have to say, well, stop clicking on the button. I've got 10 emails since you started doing that. But obviously, again, it's the post-mortem type analysis, right? It's really impressive in terms of the detail it captures into these trace backs and kind of root causes of these errors. So this is a screenshot of our live one, but it's real helpful to have this kind of system connected to your production system. It's a way to get live. If you've ever spent too much time digging through log files, you'll definitely appreciate having this capability and the amount of information that this can provide to you in a very quick manner, or in a very concise manner. So installing Sentry, to me it's as simple as I created it in a virtual environment to isolate it, and it's just pip install Sentry and then probably your database driver that you're using to store the results. The Sentry package pulls in all of its own dependencies. It should really be this simple. And then because Sentry is really just, it's built on top of Django, you kind of create a Django type of configuration file. So, obviously I abbreviated some examples. You configure your database, name, host, password, etc. You give it some specific options. It has its own internal copy of GUnicorn, where it runs all of its workers. It runs its WSGI. And the other big one tends to be you configure email, right? It kind of only has two purposes. It captures the data, and it alerts you to these events. So it's relatively straightforward to configure as well.
You don't prefer to use the hosted Sentry?
This slide. Or use the hosted. So it's one of those, again, it's philosophical. I tend to like to control as much as I can, unless it becomes too burdensome, which would be my counter case for something like running your own SMTP servers. I'm happy to pay someone else to deal with that day to day and fight that fire. This, to me, requires so little attention that, I installed this 9 months ago, and I probably haven't looked back at it. So, and I actually, again, hosting, same thing. I actually run it on the same app servers that I run the live system.
So all your support services, you use GitHub hosted, and everything else you host yourself. That's your preference?
Generally, yeah. And again, obviously, it's very subjective. Like I said, I gave you that artificial boundary, the amount of attention it needs.
Right.
A lot, someone else can do it. A little, I'll happily inherit it. And Sentry's in that latter category for me. So configure Sentry, to run. I kind of use supervisor D, which you'll see in the deployment section, as the ultimate kind of process manager. It's a again, Sentry has its own command line when you install it. So it's as simple as Sentry, you pass it the path to the config you just defined, start HTTP, and that command will run GUnicorn services. And if you looked back here, you told it to run, in this case, all hosts are, all addresses, port 9000. You could obviously, probably should have done 127 or something if I was worried about it. And then, of course, I've got the app server running, and then I just run, I have Nginx in front of it, which in this case will proxy pass any access to this host to that app server.
Do you ever double up on like EC2 instances running Sentry and something else, or do you keep each?
Well, that's what I mean. So in my current company, we don't have too much usage right now. Again, so we can I literally have Sentry running on the same server as my app servers. I've had other companies where Sentry can compound a problem. So we've had instances where, like, say your server crashes every time a request comes in, which it then needs to trigger an exception, which needs to transfer over to Sentry. And now Sentry is getting, saturated. And I had cases where that basically.
Mixing those with, say, Sentry and Jenkins, for instance.
Yeah.
Support services.
Yeah, and you can do that too. And again, like I said, in my case, I like, because Jenkins Master, I literally put on in the smallest T1. Sentry, I think, needs to be a little more responsive because it can be in the request flow. So I actually just tend to treat it as another app, it's another WSGI app that we're running on our installation. But like I share the database too. You can create different databases, to try to isolate the stuff. And that's the nice thing, again. The thing I'm generally not going to cover, because like I said, I focused on, small, earlier stage projects, but a lot of these processes and systems can easily be, compartmentalized, split, architecturally as you scale up. So you obviously could run your own Sentry on its own isolated system just as easily as you can kind of share, the installation with other boxes.
Do you run your tests on the same instance that Jenkins run, or do you spin up on EC2 or some other place to?
So the way Jenkins was configured is it actually spins up a new box every time it runs a test.
I see.
And I mean, technically, it will keep the box running. It won't literally spin it every time, but it's on demand. So it'll spin up a box, and then if it doesn't see, there's a timeout setting in the EC2 plugin for Jenkins.
I see.
And I set it to something like a half hour. So if you're constantly pushing code, it'll just keep reusing that box. But otherwise, it'll shut it down and wait for you to, push a new code and then spin another instance. So, but yeah, the engine. Again, if you're not familiar with Nginx, obviously this is a resource, and there's better sources on how to configure it. But it's relatively simple. All you're doing is saying, redirect or push every incoming request over to Sentry, which is running on that port 9000. That you configured. And as we jumped ahead, you don't need to. Sentry is in development basically to support a hosted solution. I can't remember what it costs, 20, 30 bucks a month or something. It's not very expensive. So again, you're welcome to use that as well. I think that was the other, I guess I skipped over that. The other thing I like about running it myself is the connection between the production system. Since it does direct the error reporting can be local host or can be local network versus a hosted solution that has to go WAN and back to report an exception. So there's a responsiveness that you have having this in your production environment or in your shared environment that you wouldn't get if you distributed it over different hosting environments. Okay, so that was obviously the server side of Sentry, and then you also need to configure Sentry into your application itself. So for Django, it's relatively easy. There's just a few configuration variables. Sentry has what they call a DSN. I have no idea what it stands for. But it's kind of a URL/authentication token. It's once you install it, it'll generate one for you. So you just copy and paste. A couple other things, you can add a middleware class. That's the Sentry 404 catch middleware. For Django, which is nice if you we use if it catches all those 404 errors, so you can report those. It's great if you're finding 404s you didn't expect. If you're missing something, your URL conf is off or something. And you also want to set a logging. So this again, all these are obviously Django specific, but when you configure the logging for Python in Django, you're going to want to add the Sentry handler. So any logging messages get communicated over to the Sentry server for storage. So just some extra things. Again, these are on the optional side. I create a second DSN variable I call it public. Because there's a project called Raven.js. Raven is the client complement to Sentry. So if you see that elsewhere, that's their client side of the code. They have a JavaScript version, which is nice. You can actually load into your page. And if it triggers, if it captures an exception, it'll report it also to the Sentry server. But you have to share the token with the browser client. So you really don't want your private key. So you tend to use host access control, like the origin host and stuff, is the primary way it protects inadvertent access. And then the other example is you also want to set up a logger for Celery if you run Celery. So you want any log messages generated by Celery to be transmitted over to the Sentry server as well for exceptions that happen in that, because they don't happen. In Celery, it's not operating within your request response flow. All right. So I think this is the last stage is to talk through some deployment practices. And kind of like I like to split up deployment into a couple stages. I had no idea for the title. I just called it spawn servers, right? I just want to have running infrastructure. I want a network attached system I can use. It's that foundation. So a decade ago, these were servers you bought, installed, rack mounted, et cetera. Now, obviously, the cloud-based infrastructure is probably the most popular. And in our case, again, it's one of those. And the key to having these separations is that by splitting them up, you go through these practices at different rates. So, like I have spawn servers. The second one I have is what I call configure services and installations. It's getting a bare vanilla server system, prepared to serve your application. And then the final stage is actually getting your application installed and configured on the box. And the value of separating these is you perform them differently. I probably have done that initial stage of spawning a new server or configured a server a handful of times, right? You tend to create that server and you're done. You configure the host name, the IP address, the DNS. And that server tends to operate. Obviously, at some point, especially if you're cloud hosted, it can fail. If it's your physical hardware, obviously the hardware can fail, and you'll need to repeat the process. But this isn't something you tend to do every day, at least not at the scale I'm suggesting with this smaller footprint. The second one is when you configure. So this is now again installing the database, installing the libraries. Again, not something you do all the time. You tend to not have to repeat this every day. But maybe you add new dependencies, you tweak your settings. You added something new to Nginx configuration. You need to adjust these. And then the final one, that final stage of deploy applications, is something, at least on our team, we literally do every day. I mean, you're constantly pushing your new code up. And so because of those different frequencies, there's a different kind of return on investment. This later stage of deployment is where your best use of your time is to automate and make it very repeatable, right? Because that's where you're spending the most of your time. Making something like configuring new servers, isn't going to be the same, and that's kind of why I highlight it. Like to me, I'm happy to just use an AWS console for EC2 or whatever it is. I can just log in and say create a new instance, and I can spend 5 or 10 minutes because it's something I only have to do once a month, or or something like that. But the cost of having to spend the same 5 minutes deploying my application would add up. It would add up to to hours and days over time.
Just real quick, as far as like choosing SaltStack over some of the other configuration engine servers, were there any technical reasons to go with SaltStack or say Chef or Puppet?
So quick caveat is, to me, SaltStack is the one that's not really qualified in the context of like easy things to do.
Yeah.
SaltStack is itself a weekend. I've been running a clock. I'm probably at about 70 hours configuring SaltStack. I've been to other presentations in this type of environment where it's like I've been promised anywhere from 10 minutes to an hour. And that's great, but that's also like the 5-minute blog demonstration. So just let me, so specifically, personally, I've used Puppet Chef and SaltStack. I found SaltStack better matches the type of environments and type of processes I was implementing, but it's heavily biased by you're starting with a relative novice. And so, and my requirements are so low that I'm just trying to automate things that I've been doing relatively manually. So I probably rarely got to a point where they've really differentiated. So, you have a question?
I was, regarding that question, I was in the Scale conference. I took a chef class, and it took him a while. about 3-4 hours to lead the whole class just to install an Nginx or an Apache Tomcat.
Yeah.
So the learning curve for that, I would say, is probably higher than SaltStack. That's number one. Number two, a SaltStack is a Python based. So if you're not if you're a Python shop, you're better off going with that. And in some respects, you have to do more programming with Chef.
Yeah.
Yeah, so that's the thing that I'm coming from. Yeah, sure.
As an alternative, Amazon's got their own hosted Configure Your Box platform.
Mm-hmm.
I've never actually used it, but I saw them use it at an AWS conference.
Okay.
Yeah, could be. But you JSON style configuration.
Okay.
Installs packages, can install things via pip. You can provide script installs, things like that. It seems to work pretty good.
Yeah.
Personally,
Okay.
I usually just set up a machine, create an AMI, and then just spin it up anytime I need it. And anytime I upgrade the one machine.
Yeah. And
Anyway.
that's what I mean. You'll see, it's one of the closing points here is,
Yeah.
Again, the SaltStack is the one. I kind of anticipated that if I'm going to have to talk about deployment, I should probably at least position, that there's an eventuality you'll eventually want to migrate to something beyond, the kind of, fat finger based or copy and paste based configuration. But it's definitely the one outlier in this presentation where it's beyond the scope of really this like rudimentary or a really simpler side of adding some capability. If anyone's interested though, I did spend the 70 hours. I'll show you. It is very powerful once you have it in place. I can spin up our entire infrastructure in 10 minutes through Salt. So just some more context. Again, this is, obviously it's simplified to some degree, but really this is the production environment we're trying to deploy to. So we've got a couple, we've got MySQL and Redis, which are two of our data stores. We have Nginx as the front server. We got MicroWhiskey running our Python Django applications. We also have Celery processes. Obviously the relevance is, the two process managers. We have Upstart, the built-in, I run everything on Ubuntu 12.04. Upstart can run those kind of built-in packages, and then we use Configure Supervisor D to manage the more app-specific components. So I kind of already covered through all this. I mean, I have no magic bean. I literally don't have any automation in my ability to create instances. I'll just configure them, click buttons and so forth. Obviously, there are opportunities. If you use Amazon, Python's library is called Boto, I don't even know how to pronounce it. But there's plenty of ways you can automate it. Just hasn't been a real pain point or need on any of my projects.
You guys have chosen not to use CloudFormation.
Again, just hasn't hit the pain point. One aspect, this is very, my perspective tends to be I get very nervous about lock-in. So I tend to avoid a lot of these value adds like Beanstalk or like same thing with simple what is the SQS or something. I'd rather have Celery or my own queue for some portability, some options like that. But crap. Technical difficulties. My computer is, like I said, these are the two paths I'll go. But obviously, again, just kind of high-level stuff, right? It's getting those services on your system, whatever they are, databases, network services, whatever components make up your architecture. Basic sysadmin stuff, configuring the system. And then again, I kind of outlined some of our key services. I need Nginx running. I want Supervisor D, Redis. I have MySQL. You need cron scripts, different kind of components in place. This is what I did up until 2 weeks ago when I invested that weekend into SaltStack. Is I just, it's a list of commands. And again, just run this. And so real easy. We actually use Percona, which is a fork of MySQL. Some dependencies. These are all the Python libraries. Our dependencies we'll need when we run our pip installs. We need Node.js for like CoffeeScript compilers and some other asset management. But this would be, to answer that question about salt, like you can get 90% of there with just keeping a file like this up to date. Or at least at this early stage, right? And there's not, and that's more important than diving into salt and trying to get everything really automated. Depending on the number of servers and how much time and resources you spend on it. But by comparison, this is our salt top file. So, the main goal, because again, I'm not going to have an opportunity to really explain salt, is it really does a lot of the same functionality, right? Salt gives you a lot more expressive capability. So in this case, I have roles. If you're a web server, you get Nginx. If you're an app server, you need Redis and Node and Supervisor. If you're a DB server, you need all the MySQL and support systems, right? And and that question of, again, it makes it really easy. I can choose to put them all on one box, which I'll do, say, for development or testing, or I can spread them out onto different boxes, with different deployment policies. So we can have a much more scalable system in production. But again, it's all the same code and deployment. So then the final step, and like I said, and think about it again, the easiest path is recommend for actual app deployment is just use something like Fabric. You actually can use Salt to do all the deployment just as well. I will probably eventually convert the Fabric deployment into a Salt execution module. But again, that tends to be outside of the scope of these kind of like more, the easier path. So think of Fabric as just kind of a little bit better structured, kind of bash script way to configure it. Obviously handles, the remote connectivity and SSH. But this is our actual deployment sequence. We run these 9 Fabric tasks serially. So I'll explain it a little later. I have an enter maintenance task, which is what it'll do is it'll trigger like under maintenance message on the system. I'll check out the code version, based on the tag version, SHA-1 or branch that we want to deploy. It'll do a clean, which is like, it'll get rid of the PYC files and stuff and make sure there's nothing lingering. Install dependencies. We'll run pip installs on the requirements file. This is a little Django specific, but I'll run the migrate south command. Make sure the database is up to the right version. There's some asset management. The static assets is where for static files, which again is a little Django specific. It'll get all of the media and JavaScript and CSS and everything compiled and configured. There's a flush cache step if you have anything like memcache or anything you want to clear out. And then you reboot the bounce the app server itself. Use supervisor D to reload. In this case, it's micro WSGI. And then obviously exit that earlier maintenance.
For deploys that don't touch the database, have you ever done rolling deploys without an outage?
So that is part of the caveat here. Is again, I haven't had an application where you can either time or these deploys are fast enough where they don't actually create impact outages. To orchestrate something like that, there's a few steps you can take. Certainly if they don't touch the database. If you have multiple app servers, you can stage them. You can either stage them by having Nginx have multiple upstream servers, and then you go one at a time, and it kind of handles the round robin. Or you can use something. Micro WSGI has a lot of capabilities with its Emperor and Zerg modes.
You don't use ELDs, you're using Nginx to do your
yeah.
bouncing? Oh, okay.
Yeah. And again, that's what I mean. There's a lot more capability you can add,
Right.
before and after.
Is there a dedicated Nginx box? Just
Yeah. Yeah. So. And the real takeaway, though, of course, like I said, it's not, there's real value in having this automation. But if you're not there yet, step 0 needs to be just kind of a PSA, is just making sure all of your deployment is well documented. And as I said, at a minimum, I showed you on that one slide, every command I took from, I always start with a vanilla, like Ubuntu 12.04. And I want to have a list of commands I run. Any version control, your settings files, whatever, make sure those are version controlled. You can retrieve them again. I tend to do something like this, where I'll check out a repo and link the version. So ensured that what's running in production is captured in version control. You know, and it's obviously easy to forget this stuff, but it's like disaster preparation. Like you only get burned like when you really need it. So the more you kind of take the time to prepare this, the more it's valuable. So, a couple tips on the deployment side. So it's relatively easy to wire up Nginx and MicroWSGI. There's a MicroWSGI protocol that Nginx speaks. So you just do the WSGI pass and give it. You can either use, I tend to use TCP IP sockets, but you can use Unix sockets as well if you're staying on the local box. I add the one WSGI parameter scheme, which helps it, tell your app server whether it's running under SSL and which your system might take account of. And then again, I told you I run supervisor D. So you just supervisor D, you just generally give it a command and then some additional attributes. So in this case, and I guess I cut it off, but you can see it in the slides. MicroWSGI has a fair amount of options that you give it. For parameters, obviously the key one is to have the listening socket match the one that Nginx is expecting for them to sync. If you remember, go ahead.
Be careful with your versions.
So the next tip I want to share is it's a nice little feature if you want to add kind of a maintenance window capability. It's a way to take your system, put something currently under maintenance. It's kind of a trick. You use Nginx has kind of an IP-based capability, like a GeoIP. And what you do is you specify. It's a way to tell. It's to set a variable based on the source IP of the connection. So what you do is you configure, so in this case I call it geo, the variable's name is maintenance. Default is what kind of everyone else is going to see. So in this case I'll set them all to 0, but I'll default to 0. And then you tend to specify a whitelist of IP addresses that are going to be you or your systems that you want to still be able to access the real endpoint while you're fixing, pulling plugs, whatever you're doing to resolve this anomaly. But everybody else, and so you can see I have some local addresses, and then I tend to hard code in my office IP, home IP, whatever you need, right? So you get privileged connectivity, and then when you have, so everything's location based in Nginx, you do a test on that. And so if it's, in this case, I did an if maintenance, so if maintenance is not 0, it returns a 503, which is, later in the configuration generates a, under maintenance type of error page. So again, this tends to be, I guess it could be planned, but it's not automated. So if you ever get into this situation, you can just go into this file, change that default from 0 to 1, bounce your Nginx, and then everyone who's not in that whitelisted of IP ranges will see that error message page, right? So it's a great chance to prevent all those, your log files from getting out of control, whatever is causing, that kind of mayhem, to contain that while you still have access to the system and can keep testing and resolving whatever, challenge you're facing at the time. So the complement to that is, you saw I had a couple tasks in my Fabric deployment that actually generate during the deployment. It'll also generate that kind of under maintenance page. And the way I did that is, it's separate, is that I use the try files command, which goes from left to right, trying the different endpoints to resolve that request. Is I insert, I named it maintenance.active.html, which is a file that normally doesn't exist. So try files will constantly fail to hit that. And in this case, for that location, it'll hit my MicroWSGI endpoint. And then when I showed you my deployment task, all I do is I basically create and remove that file at the beginning and end of deployment. So in that intermediate time, anyone who hits your service is going to get that error message because